And we have nothing. But we have not messed with the controls yet. Hey guys, welcome back to the GE Color Roundie Restoration Project. The parts are ordered, are supposed to arrive tomorrow. Meanwhile, there's some stuff we can do with what we have on hand. In particular, we have an open thermistor. I think a CL90 will work just fine. I'll clip out the old one, bend some leads around and install this. So I measured the cold resistance on this guy, and it's measuring 120, which is exactly what a CL90 does. I don't know what the hot resistance on that will be, or is supposed to be, because there are no specs or part number in the Sam's Photo Fact, but this is a really common part, rated for a couple amps. I think it'll do all right. We've got this, or had this cap across the AC line. I'm taking that out. Replace it with one of these ceramic guys that's good for both X and Y. In other words, across the line or either side of the line to ground applications. Very common. I use kind of a universal replacement for these death caps. Now, for the rest of it, all these brown or maroon Elmenco seem to be Mylar film and they're fine, but there are two white caps. Here's one of them. It's an Elmenco like the others, but it's in a white ceramic tube rather than being in a brown plastic package. It's 0.001 microfarad, also known as 1000 picofarad, rated for 2000 volts. There's no series. It's not like it's an X25 cap and I can look up the data sheet on it. This is all I know. I've seen very similar looking ones online listed as both being paper or plastic. I honestly think they aren't sure either. So we're going to clip one end of it out, put on a cap tester, and see if it's leaky or not. There's also a 0.0047 on top. I think it's rated for 400 volts. We're going to double check both of them. Alrighty, let's get it hooked up. I unsoldered one lead, one that was going to the chassis. So here we go. Now, this test one goes up to 500 volts or so, but at least it'll give us some indication. If it's leaky at 500 or less, we know it's most definitely bad. And no, it does not appear to be. I do have another tester and go up to 1,000, but I definitely don't have anything to go up to 2,000. Now I'm putting the leads across that cap. The one that was across the AC line. So make sure my tester's working right. So yes, this is most definitely very leaky. Go back to that other cap again. See, 2,000 volt caps just don't grow on trees. I don't know if I have one on hand. I might have to throw a couple 1,000 volt caps in series. I'd hate to replace it just because, rather than knowing that it's actually bad. Alright, let's see if we can test for capacitance. See, I can't test for capacitance. It's not giving me a distinct eye, which is a good indicator that it does have a problem. So the 3 range, it should be right around in here. And I'm just getting around 0.003 or 25. I'm getting a hazy indication in the eye. It should give you a really distinct open pie wedge when you're on value. And I'm not. So even though I can't test as a full rated voltage and it's not showing leakage at 5, the fact that I can't measure the value is not a good sign. So I think it does need to go. I'll hunt around. Ideally I would have a nice Sprague orange drop 2000 volt cap handy. I don't. It's a 1.6 kilovolt. 0.002. So like if I had 2 of these, I could put them in series. When you put caps in series that have the same value, the capacitance would be cut in half. So this would go from a 2,000 to a 1,000 picofarad cap. And you double the voltage rating, so instead of 1,600 volts, it'd be good for 3,200 volts. Let's see, do I have another one? It's a 1500. What's this? Oh, it's another 1500 rated for 1600 volts. It's a 1500, 800 volts. So I'll hunt around in here. I almost guarantee I don't have a 2000 volt cap handy. 1500. Isn't that a sight to behold? Look how clean that is. And these sockets look awfully familiar because they're exactly the same type as they use in all those Philco predictors I've worked on, except these are the more robust type with a little bit thicker metal on it. I've spot checked a few of these resistors and they're within spec. Other components on here, we've got a bunch more of these brown, presumably Mylar caps. There are some things you might not recognize, like this. Looks like a piece of cardboard with two wires staked to it. There's a coil on the other side of it. And you can see one peeking out down here. I don't really want to bend them up. Well, you can definitely see one here. So it's another way of making coils, and I started using this as they switched to circuit boards, where they take a coil and they wind it and then just affix it to a board and have two wires coming out of it. A little fragile. You want to be careful when you're working, like if you had to replace some of these parts, because it's just hanging out there. It's not encapsulated or anything. It's pretty easy to damage them. Hopefully this will be the only area I actually need to do any work. I want to replace this axial electrolytic, and here's that other white ceramic tubular, probably paper cap capacitor, so we're going to replace that guy. Everything else I'm just going to clean for now. It all looks great. Alright, let's try this again. So the chassis back into the cabinet, just threw in a few screws to secure everything, plugged everything back in, except I didn't bother reattaching that focus lead, and the horizontal output tube and damper tube are out, so there won't be any high voltage. We're going to resume trying to reform caps. Got the variac turned down all the way. It's on, the set's turned on. Let's go up a little. Alright, we have current draw. Putting in, well, let's get to 10 volts. So, going to monitor that needle and slowly increase. So typically when you do this, assuming we have B plus now, is I'll increase this, the current draw will go up a bit and then come back down a little. That's the leaky capacitors forming back up. Alright, so here's what I'm looking at. Been slowly dropping for about 5 minutes. It's pretty well stabilized. I'm going to turn up the variac a little bit. See, the current went up. But as we watch, it should drop a little bit slowly. And it is. Let's watch the needle compared to the tick marks. So you let it sit. Maybe each time you increment the voltage, let it sit 5 minutes or so. Or keep watching that needle, and when it stops moving, you can go ahead and increase the input voltage. Still slowly dropping. So actually two things are happening. It's not just about forming up the caps. It's also these tubes. They have cold filaments, which have a low resistance. As they warm up, the resistance goes up and the current draw and the filaments drop. So we have two things that are decreasing the current flow. One is the tubes heating up, and the other, hopefully, is the caps reforming. I've been slowly working my way up. We've got 50 volts going into the set now. Drawing about 0.7 amps. Now how can I tell if it's just the filaments again or B plus? Simple. You can push the circuit breaker. And it drops. And let go, it goes back up. So, we know we have B plus. We know the circuit breaker is working. Excellent. I worked my way up to about 115 volts into the set. No problems whatsoever. So, I put the shunt regulator, the high voltage rectifier, the damper tube, and the horizontal output tube back in the circuit, and I rigged up this guy again so we can monitor the current. Let's go for a full power up. On the 4-amp scale here, so drawing a little over an amp. As the tubes warm up, that should start climbing quite a bit. Starting to get some current draw on the horizontal output tube, but it's barely anything. Variac dropped a bit because it's drawing so much power now. So let's get that back up to 115. Drawing about 2 1/4 amps. Oh, horizontal output tube. Yeah, that's. Oh, and we have high voltage. If you guys could hear that, it's a very noticeable of static electricity. What are we drawing? About 150, and this says 220 on the front. I'm guessing that's like a max. So, let's see our total current draw. Just a little under 2.5 amps. I'm running the set a little bit lean though. Probably have just a bit under 115 going in. Alright, well I guess we better take a look at the front of the center. Now, if you have high voltage and you've got filament draw and the CRT test strong, it'd be pretty hard to get no image out of it. There it goes. Had to turn the brightness up. I did bring my portable NTSC generator with me so we can hook that up. And now you can see the effect of a cataract. I actually haven't seen this before. So, if you were thinking, well, maybe it wouldn't be that bad when you're watching the set, yes it is, and no you can't. So we just have a little window in the middle where it's still good. Now I'm hoping this plays to our favor, because if you go by square inches, it looks to me like, assuming that this is all loosened up, that we're about halfway there already. Meaning this entire, a good chunk of the outer band all the way around is loosened up, so we just need to remove this center part. Well, isn't that cool? So, and the tuner is doing something. Oops. Boy, this on-off, pull-on, push-off switch is so touchy. I've accidentally done that a few times. Excellent. I'll leave it on channel 3. And let's hook up our pattern generator. Now, in spite of the cataract, I can see that we're not getting all the way down to the bottom there. So yeah, we have controls, we have centering and whatnot, but that could also be an indication that some of those caps just aren't completely healthy. That's a really common issue you see when the vertical output tube cathode bypass cap is leaky. The bottom of the screen starts creeping up. Well, two things just happened. One, I was trying to hook this up and realized I left it on for probably several weeks, and this battery's completely dead, so I got to replace that. Two, just as I noticed that, the TV turned off. I think either the circuit breaker on the set tripped, or my CR70 still appears to be on. So we got to figure out. Everything was running super stable though. I was watching the current and everything was rock steady. But we know that that circuit breaker in the set's kind of flaky, so I'm hoping that's all it is. Yeah, circuit breaker popped on the back of the chassis. We are back in business. I got a feeling that's going to be a common issue with this pattern generator. It's really easy to leave it on. So let's see, let's go to channel A and color pattern. Well, sounds like it's doing something. Kind of, sort of, maybe. I'm not sure what channel I left that generator on. It's on channel 4. Well, it's not very good reception, is it? Oh, yeah, no, it's doing something. Oh, and there goes the breaker again. Proof that that breaker is just on B+, because we still have our channel indicator illuminated. I think we're going to have to replace that breaker. The set is not drawing an excess amount of current. I turned down the variac a bit, so I'm running the set maybe 113 or so, and the breaker hasn't been tripping again. Also fooled around with my pattern generator, which is cheap, keep in mind. It's not the greatest device, but I did finally get everything to lock. I'd had to get in here and fool around with the hold controls and whatnot a bit. So you may have heard of convergence. There's all this little panel with 9 pots on the back. Well, this is what happens when things aren't converging properly. Red, green, and blue phosphors, and they're in a green, and blue gun. And here you see that you end up with a black and white picture if everything's lining up. But down here they're diverging, so we can actually see the individual red, green, and blue areas. Now, I presume that these are supposed to be color bars. And yeah, okay. At first I thought there was no color at all, but yeah, there is. It's just not very bright. I'm adjusting the color. Here's a little color control all the way down and all the way up. So it's hard to see with a cataract, but yeah, that's reddish. That's getting blue purplish. Maybe it's green. This generator does not do the standard official test pattern. This is just some simple color bars. I don't even know what the colors of the bars are supposed to be. I will get, now that the set is coming to life, I will get a more sophisticated pattern generator on it, so we're not fooling ourselves with inadequate test equipment. That being said, the final one does say purity, so I'm thinking that you get pure red, green, and blue with each of those. So here's one position, and another, and another. It's the same no matter what I do. Or maybe that's just to check that it's an even color over the whole thing. I'll have to read the manual on this device and to find out for sure. So this is supposed to be sort of a gradient color from one side to the other, and yeah, we kind of have that. Now these controls are probably all horribly misadjusted, so I was just playing around with it. So tint might be completely wrong. I'm playing with it now. But yes, we have color. We very definitely have color. So we have tone, we have, we have tone, we have tint, and we have brightness. So let's see what tone does. What's the difference between tone and tint? I'm not sure. But I can tell you that adjusting tone doesn't do really much of anything. It's also really hard to control the turn. That's why I grabbed a screwdriver. It was frozen. So I'm manipulating it now. Not really doing anything. Alright. But on the bright side, no pun intended, we have a very bright, strong CRT. That's a very good thing. And we're just hearing a buzz. I don't know if this generator actually produces sound or not. Definitely have a dirty volume control too. Let's go to a crosshatch pattern. So I want just fine tuning here and see. Yeah, it works. Kind of interesting the way this tuning works. So when you're doing VHF, change channels up here obviously, and you pull this out for fine tuning. When you get to UHF, you push this in, and this is how you tune, or you just leave it in its normal position. That's how you tune the UHF. But otherwise, you pull it out for VHF fine tuning. Well, what the heck? Why don't we just get an over-the-air converter box and see what this baby can do? I can also, on the back, I think there are height and vertical linearity controls, and then there's centering controls too. I'm sure we can get it better than it is right now. Alright, over-the-air converter box. Is it channel 3 or 4? Don't recall which. I guess it'd be channel 4. Alright, we got something. Looks pretty bad. That's why we're having crummy sound. Or crummy, dirty volume control. We're having crummy, or we had no sound and crummy color because I had to tune the fine tuning. I think it was a breaker. I had to tune the fine tuning so that the picture actually looks terrible, but then the color info starts coming through. It's promising though. So I wonder, now the 2 tubes I didn't check are actually in the tuner. Kind of hard to get at, and I lost track and I never got around to testing them. And all the rest test like new, so I figured I didn't need to. It seems unlikely that the alignment could be off so bad. Honestly, for a first full power-up, I'm very, very happy. I wasn't expecting perfection. Barely done anything to this set yet. And at least in the middle, grainy though it is, the live video looks pretty good. And that little portable pattern generator is not the highest quality, so I'm not going to be too concerned about doing convergence or anything. Plus, if it is off, it's going to be more visible at the edges, which is so cloudy we can't see it anyway. So that's going to come much further down the road. So what do I want to do next? Definitely replace that circuit breaker. If you recall, when I was cleaning it, the resistance was still around 3 or 4 ohms. It should be close to 0. Ideally, it would be 0. So I'm thinking it's probably not making... It's warming up, and the heat is what makes the circuit breaker trip, so I think that's what's happening with that. They're out there, I'll get a replacement. Likewise, I'm going to get a replacement socket for this CRT so we can deal with that wire coming out. There are some diodes in here I was planning on replacing, which I haven't done yet. One of them being the focus diode. It's hard for me to tell if the focus is good or not because we don't have a very good picture. Also some AFC diodes I could replace. And there's a selenium rectifier stack up on the convergence board. This thing has been advised to me to replace that. Also, there is a chunky power resistor up in front here. And mine tests good, but it does get pretty darn hot. And again, I was recommended if I'm in here and I'm doing work, might want to replace that with something with higher wattage rating. Similarly, I was advised to swap out the cap that goes from the plate of the horizontal output tube to the grid. Sorry, the plate of the horizontal oscillator to the grid of the horizontal output tube. And I want to get a better replacement for that 1000 picofarad 2000 volt cap. In other words, I'm going to need to order some more stuff. The drag is that I may have to use a different source for each one of those. CRT socket I'll get off of eBay. Circuit breaker, maybe Talon Electronics. The cap may go back to Mauser. So it could take a little bit of a while for me to get all the bits and pieces I need. Meanwhile, I can tinker with this set a little more and especially test those tuner tubes. And then, of course, we have another color set lurking in the background. So I might just put the cover back on this guy and put it aside and start looking at the other set while I wait for the parts to arrive. That's going to be it for now. Thanks for watching.